In this video, we're going to take a look at multicast listener discovery. Now, multicast listener discovery is used on IP infrastructure layer of the IP next generation network. It is used between the customer and the service provider edge devices. MLD snooping is used on access and aggregation devices. So, what is it? To implement multicast, routers should know which users should receive the multicast traffic. Like IPv4, we use IGMP. So, is that similar? Well, MLD basically is IGMP. V1 is similar to version 2. MLD version 2 is similar to IGMP version 3. MLD handles joins and leave processes on the access segment between the listener and the first multicast router. So basically what it does is when a receiver says, hey, I want to join that multicast network, an MLD join is sent to the last hop router. The last hop router then converts that to a PIM join, and that PIM join hits the receiver, or hits the RP. Therefore, a multicast tree is built between the RP and the last hop router. Some of the MLD version 1 messages. You have 3 messages. You have a query, which is the general query, the group specific and multicast address specific, report, and done. Message specifics, you have the query, which is the group specific, set to 0 when MLD sends a general query, learns which multicast addresses have listeners to an attached link. The report is used to indicate receivers listening. Done indicates receivers are no longer listening. Now, MLD version 2 is slightly more enhanced, like IGMP version 3. Support for source filtering. Node can select a source for a specific group. Interoperable with version 1, which means it's backwards compatible. Analogous functionality to IGMP version 3 for IPv4 defines new messages. Now, some of the access groups and group limits. Access groups enable access control for multicast group receivers on an MLD router. So limits the list of groups that the receiver can join, denies or allows sources that are used to join source-specific multicast channels. Group limits control a number of groups on an interface and can be implemented either globally or per interface. If you go to the interface, you're being more specific. Membership reports exceeding the limit are ignored. MLD snooping. The default behavior for multicast switch traffic is to flood it to all layer 2 interfaces in the same VLAN. So this is where you have a switch with multiple receivers attached to it and potentially a single uplink to a multicast router. This could be your last hop router. A high volume of multicast traffic loads a switch data plane and control plane. Because by default, a switch doesn't know what to do with it, so it sends it everywhere. So it's used to determine and store information that switch ports receive data from multicast groups. Layer 2 ports that do not have any listeners do not transmit multicast traffic. If a multicast group has only sources and no receivers, multicast traffic to only the multicast router ports. So it knows who's receiving who. So basically it sniffs the traffic. It looks at the layer 2 header, sees where traffic is going, and then it's able to help identify what's going on at that level. Some of the caveats that come along with that is MLD snooping is available only on switches, available for both version 1 and version 2 MLD. Snooping monitors layer 3 MLD traffic. MLD snooping proxy, the first report to tell the MLD router is sent, while all other reports for the same group are suppressed. Just to let more of a, I only need to send it once kind of deal. Snooping join group. Hosts join a multicast group. Switches create a layer 2 fib entry for the multicast group in this VLAN. When additional hosts want to join this group, the switch adds its ports to the layer 2 fib for the group.